Okay. Rational expressions. We're on lesson 5. We're skipping lesson 4.
It's on page 93.
Sure, you can cross it out. If that makes you feel good, cross it out. It's not in the curriculum, so we don't need to cover it. Okay? There's a few lessons like that. So let's first talk about the word rational. What do you remember about the word rational? Ratio. Another word for ratio. Oops, I wrote ration. Well, what type of decimal? Non-terminating. Or, no, it is, sorry, rational is terminating. So terminating or repeating decimals can be written as fractions. Excuse me. Yes. So you can go home and watch it if you're like still confused. Okay? It helps. Investigate the meaning of 1 over n. So we're going to talk about rational expressions. So rational expressions, in the term that we're talking about, are fractional exponents. So rational exponents are the same thing as fractional exponents. So exponents with fractions. Yay, everyone's favorite thing.
No.
Because we all love fractions.
All
right, what does root 5 times root 5 equal? Root 25, which equals 5. Okay. Now, when we have the same base, so let's say I had 5 to the power of half plus our times 5 to the power of half. When we have the same base, what do we do with our exponents? Add them. And what is 1/2 plus 1/2? 2 over 2. When you add fractions, we need the same base. We add the numerators and leave the denominators the same. So 2 over 2. Okay, which is 1. And that makes sense. If you have half a pie and another half of a pie, you have 1 pie to eat. Okay, so looking at that, notice the relationship here. 5 to the 1/2 is the same thing as what? If those both are equal to 5. It's equal to root 5. Kind of led you there. I'm sorry. 5 to the 1/2 is the same thing as a root 5. It's the exact same thing. So remember all the stuff we learned about radicals? That's going to tie in with this lesson. So when you have a fractional exponent, you actually have a radical. Cool. Okay, so 2 cubed times 2, cubic root of 2 times cubic root of 2 times cubic root of 2 is equal to cubic root of what? 2 times 2 times 2, 8. And what is the cubic root of 8? 2. Now, if I have 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3 with the same bases being multiplied, we're going to add the exponents. 1/3 plus 1/3 plus 1/3. 3 over 3, which equals 1. 2 to the power of 1. Okay, so that means that 2 to the power of 1/3 is the same thing as cubic root of 2. Now, you've already actually done this. You just might not remember or didn't realize that you were doing this. Because remember when we were simplifying, let's say, the square root of x to the 6? What were you dividing? 6 from what? You did 6 divided by 2. You took the power and you divided it by the index, right? Do you remember that? You've been already doing this. And so the same thing is a square root of 5. What's the power on the 5? If you don't see a power. A power, not the index, the power, exponent. The exponent on 5. It's 1, right? And what's the index if we don't see it? 2. And so that's why, remember, exponent divided by index, 1 over 2. That's why it's equal to the same thing. And we've already done that. We've taken the exponent and divided it by the index to simplify it. Those are the same thing. That's what we're going to learn. I like to think about it. Well, I'm rushing. Let's go into the next example. Write the following in radical form and evaluate. Okay? So 25 to the 1/2. We already said that when you have an exponent of 1/2, that's the same thing as anyone? Square root of x, right? Those are the same thing. An exponent of 1/2 is the same thing as a square root. So 25 to the 1/2 is the same thing as root 25. Okay? Those are equivalent. A square root and the exponent of 1/2. Because the exponent on x is 1 and the index is a 2. 1 divided by 2. So if you have to the power of 1/3, what is that the same thing as? A cubic root. Those are the same thing. 64 to the power of 1/3, you could also write it as cubic root of 64. Okay. What is the cubic root of 64? Does anyone remember? No, that's square root. No, not your calculator. 4. You need to memorize it. Square root of 25 is 5. Okay, so let's apply the same kind of pattern. So what do you think the power of 1/4 is the same thing as? 4th root of 81. The bottom of the fraction is your index. The denominator of the fraction is your index. If your denominator was a 2, it was a square root. Denominator was a 3, it was a cube root. Denominator is a 4, it's a 4th root. 4th root of 81, you don't need your calculators, guys, because it's square rooting it twice. Square root of 81 is 9. Square root of 9 is 3. So you actually don't need your calculator. You can do it in your head if you know your square roots. Do it twice. So let's go backwards. If you have, or apply it to a variable, that's what I meant. Hey, where'd you go? There you go. Sorry. Control myself. Write the following in radical form. X to the power of 1/2 is the same thing as square root of x. Your index is a 2. Do you have to write the little 2? No. The numerator is the power of the exponent. The denominator is the root, your index. Okay, 1/3 is the same thing as cubic root of b. 1/10, 10th root of p. My index would be 10. And so we can get to our first law, a to the power of 1 over n, nth root of a. Perfect. So I'm going to highlight that. I wonder if I can make it lighter, like less. No, that just is darker. No, let's try again. How about this? Is that like subtle but just still there? No? Okay. I know I need more colors, you're right. And then I need to go to here, and then I'm going to go like right there. Blue. That's perfect. Majestic or magenta? Blue is majestic. But my son's favorite color is yellow. I'll do blue next time. Okay, so I'll do one more. Okay, so let's talk about a to the power of m over n. Oh, that's nice. I like that. It is like the ocean. So if you have root 5 cubed, the square root of 5 cubed times the square root of 5 cubed, that's the same thing as square root of 5 to the power of what? We do the same bases being multiplied. We add the exponents. 6. Do you agree with me?
Yes.
You're just saying that, though.
No, I got it. I got it. 3 plus 3 is 6.
Okay, so we're doing the same basis we're multiplying them, right? We add the exponents. That is the same thing as, we've done this before, 5 cubed. Why? 6 divided by the index of 2. That was when we did that back when you were away. Okay. So 5 to the power of 3 over 2 times 5 to the power of 3 over 2. Same basis, we're going to add 3 over 2 plus 3 over 2. 6 over 2 or 5 to the power of 3. Okay. So 5 to the power of 3 over 2 is the same thing as 5 square root of 5 cubed. Now, the index, if it's a 2, we don't usually write it. I'm going to write it just this time for the sake of comparing. Okay, do you see how the numerator, oh, that's not a highlighter. Let's try it again. Do you see how the numerator, here 3, is the exponent? And the denominator is the index. Okay, so that's the relationship here. And we've done this before, power over root. I like to think of it as a flower power over the root. That's how I remember it. If I have a fraction, it's the flower, you know, Mario Brothers? And then on top, so the flower's on top, and the roots are on the bottom. The root's like your index. So the power is the numerator. This would be the power, the exponent, and this would be the root, or the index. Flower power over root. Oh, I'm so sorry. Okay, I need to extend this page. Oh, sorry guys, 1 second. Okay, am I here? Awesome. Extend page. Okay, there we go. So let's just jump to this. Instead of actually doing the investigation, if we know that, then what, 2 to the power of 2/3, what would be the index? Which one's the index or the root? The 2 or the 3 in the exponent? The 3, right? The denominator is the index. And what would be the exponent? 2. So that would be the power. Power over root. Reduce, deduce means like come up with a conclusion. Like you're like basically like a detective, and you're like, if this A and B is true, and B and C are true equal, then A equals C. Deduce? Oh, no. Deduce. So it's like, here, if A equals B and B equals C, what can you deduce about that? Like, what can we, it's true, it sounds funny, doesn't it? It does sound funny, but that's, then, it's basically drawing a conclusion based on some evidence. Then A equals C. Okay? Oh, no, let's go back. The very bottom there, we're going to write those as radicals. So, X will go inside. What would be, where does the 3 go? Index, where's the 5? Would be your power. Power over root. Okay? B to the power of 4/5 would be, is it 4th root or 5th root? 5th root of B to the power of 4. Okay. Shiloh, go back to your seat, please. Doesn't matter. You're not in your seat, and you guys are talking a lot. Okay? It's not, it's just, you should move to the front. Okay, what would be the index for this guy? Sorry, I should pause it. The index is 2. Do you have to write it? No, the power is 5. So square root of p to the 5. Yeah? No, I would not take marks off. Maybe if you're like in math 30, by then I'd be like, okay. But when you're first learning it, no. So what's our rule? If you have m to the power of n, which variable is the index? N, and the exponent would be m, power over root. Let me highlight that. Okay. So that's the second one. Okay, let's turn the page. Took us a while, but hopefully the rest can go quicker now. Let's get to some examples. Let's go skip down to the example number. Oh, yeah, actually we'll look at this. Yeah? B equals C? Oh, they asked me what the meaning of deduce was. Deduce? It's a deduction, right? We're like making a conclusion. Okay. I think I'd like to make a note that when you write the exponent, like here, when you have 8 to the power of 2/3, I'm just going to write one little note. When we write that as a radical, there's two ways we can actually write that. And that how you write the power, it's really up to you. So we can write this as the cubic root of 8 with the power inside, the square inside. Or you can also write that as cubic root of 8 with the power on the outside, all squared. It doesn't matter. It won't make a difference. Okay? So those are the same thing. You can write it either way. So let's go to some examples. We're going to scroll down. You can, you mean 8 squared, and then cubic root of 6. Yeah, you can do that. Often what I'd like to do is actually if I have an option of squaring first or cubic rooting first, I like to cubic root first. I like to do the root first because it's easier to make a number smaller and then bigger in our heads with mental math than it is to make a really large number and then try to cubic root it. But it doesn't matter. If you're using your calculator, it really doesn't matter. Okay. Let's go to some examples. So this guy, how are we going to write that? Write it as a radical. So what's the index? 2, and the exponent is 3. So I'm going to write the 3 on the outside this time instead of in the inside with the 25. Because, do you know what 25 cubed is? Probably not, right? But do you know what the square root of 25 is? Yeah, so let's do the square root first, and then we're going to cube it. Square root of 25, 5. So 5 cubed is, do you know what, I asked you to memorize this one, yeah? 125. Okay, next guy. Write that as a radical. I'd like you to write that as a radical. So is it 4th root or a cubic root? We're not using our calculators yet. Cubic root of 1,000 to the power of 4. Okay, so I'm going to first take the cubic root of 1,000, then let's do the power 4. Because you should know cubic root of 1,000. 10. 10 times 10 times 10. And 10 to the power of 4. How many zeros will you have? 4 zeros. 10,000. All right, let's do something new. Negative exponent. You always want to take care of the negative exponent first. Yeah. We can't flip the actual exponent. We do want to flip the number, 27. So instead of 27 over 1, we're going to write this as 1 over 27. We can't flip the exponent, but we flip the number, the actual base. So we're going to instead we want to move the 27 to the power of negative 2/3 to the denominator, then it becomes positive. But when it crosses the border, we get rid of the negative. So we're going to move it down, right? This is over 1. We're going to move it down so it becomes positive. You with me? Okay, now let's write it as a radical. So is this a cubic root or a square root? Cubic root of 27 all squared. So I'm going to cubic root 27 because I don't know what 27 squared is. I don't. You don't, I don't. And if you do, you're in the wrong class. You're like a machine. Do numbers in your head like that. It'd be impressive. Cubic root of 27 is what? 3. Cubic root of 27 because 3 cubed is 27. So 3 squared. So now after we cubic root, now I'm going to square it. 1 over 9. So if you grab your calculators, I'm going to show you how to type this in. Hey. Okay. So whenever we type in a fractional exponent, you're going to need brackets. Go second, and then mode, right beside it. There's a quit button there. Okay. If your calculator's like mine, you don't need brackets. But if you're typing it in and you see this hat, then you need a bracket. Okay, when you have fractional exponents, so you should be typing it in like that. If your calculator raises the exponent like this into a little box, then you're good. You can go negative 2 over 3, and it's no big deal. Okay. We get, push enter. You should have 0.1 repeating. How do I change that to a fraction? Math, enter, enter. Right here. Right but above the division. Okay. So negative 8 to the power of 2/3. Oh, there it is. Negative numbers, are they okay?
Yes.
Yes. So we're going to go straight to writing this as a radical. The index is, right, the root, and the power 2. So if you want to write the power inside, you'd have to write it the negative 8 in brackets, because you're raising the whole negative 8 to the power of 2. Or you could also write it, if you want to write the power of 2 on the outside, then you don't need the brackets, like this. Okay? So cubic root of negative 8, do you know what that is? Positive or negative 2? It's a negative 2, and then what do we have to do with that number still? Square it. We need to raise it to the power. Negative 2 times negative 2 is positive 4. Okay. All right, let's look at the next page. Skip G. I know. Okay, so this exponent applies to everybody inside. So the whole thing, 9 over 4, is going to go, oh, that's not a pen, inside the radical symbol. Okay, so what would be the index? 2, and then we're going to raise it to a power of 3. Now technically, did I have to write the index of 2? No, and usually you wouldn't. Usually you wouldn't write that part. You would just leave it as square root. Okay. Square root of 9 over 4, when you square root 9 over 4, do you know what that equals? Square root of 9 over 4. Well, first square root 9. What's the square root of 9? What's the square root of 9? Close. Wrong way. Square root of 9. 3. Square, yeah, you were thinking square. Square root of 4. 2. And now what is 3 cubed? 27. What's 2 cubed? 8. So, are you guys noticing something? You need to know your perfect squares and your perfect cubes. So 2 cubed, you need to memorize. 2 cubed is 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 125. You need to know those ones, and then maybe, if you don't know the others, I'm not going to stress, but 10 cubed, you should know that one. 1,000. You need to have those memorized, as well as your perfect squares. I assume you have your perfect squares because you've been working your times tables for years. If not, go home and practice them because you're going to be a lot quicker. Okay, B, what's the first thing you have to take care of? The negative. So we want to make that exponent positive. How can I do that? Flip the number. We flip the number, and then our exponent's positive. We flip 9 over 4. Okay, so this is going back to yesterday's lesson when you have a over b to the negative n. That equals b over a to the positive n. That's what we learned yesterday. What's the index? We write this as a radical now. Square root, and then we're going to do what to it? Cube it. If you want, you could put brackets here if that makes you feel better. You don't have to. Square root of 4. 2. Square root of 9. 3, so it's 2/3. All to the power of 3. 2 cubed. 8. 3 cubed is 27. Okay. We're almost there. This is the last page. Okay. So I'm going to write each. Can you try A, B, C, and D? I'd like you to try. Cubic root r. The power of 1. You don't have to write the 1. You can write the 1 if you want, but you don't have to. Next one. 7. S to the power of 4. You can put the 4 on the inside, on the outside, it's up to you. Okay, what do we have to do with t to the negative 1/6 first? Flip it. Put it on the bottom. Put it on the denominator. Move it across the border so it's a positive exponent, and now you can write that as an exponent. What's the index? 6. And the power is 1. Do you have to write to the power of 1? No, can you? Sure. Totally fine. Still shows me that you understand what you're doing. So this guy, first thing you have to take care of, the negative exponent. So it just moves everything stays the same. We're just moving it to the denominator to make it positive. And now you write that as, is it square root or cubic root? Square root. Do you have to write the 2? Nope. And then v cubed. Okay. Okay, really? Do you have to do that? 1 second, guys. Sorry. I don't. Okay. Let's go to 5. A cube has a volume of 60 meters cubed. Write a power which represents the edge length of 1 cube. So what is the formula for the volume of a cube? What do you know about a cube? Six faces, 3 dimensions. What about those dimensions? Are they the same or different? Same. They're all the same if it's a cube. Okay? And if we want volume, how would I get volume then? Let's actually call it S instead of X. So side, side, side. So it would be X cubed or side cubed. Okay? So if your volume is what? 60 is equal to side cubed. How would I get S by itself? How would I get rid of the cube? What's the opposite operation of cubing something? Cube root both sides. So one side is the square root, or sorry, the cubic root of 60. And what they want us to do is represent that as an exponent. So instead of writing cubic root of 60, we can write it as the exponent of what? What's the power if we don't see it? 1 divided by the root is 3. Remember that a cubic root is the same thing as a power of 1/3. So you can also write that as 6 to the power of 1/3. Okay? Right? So if that's what we know about our cube. Each side is 60 to the power of 1/3, or the cubic root of 60. Are we going to do surface area? Do you remember surface area of a cube? What do we know about all 6 sides? Will they have the same area? Yeah, so there's 6 of them. And what's the area of one side? How would you get that? Yeah, so, or side squared, because are they the same length? Yeah, so it would be 60 to the power of 1/3 squared. So 60 to the power of 1/3 all squared. When we have a power to a power, what do? Multiply. What's 1/3 times 2? Or 2 over 1? Straight across would be 2 over 3. So 60 times 6, 6 times 60 to the power of 2/3 is how we'd write that. Okay? And we're not going to, well, if we wanted to figure it out on a calculator, we could just type those 2 in. Do you want to type them in? Let's type them in. So the edge length, I want you to type in 60 to the power of 1/3. Figure out what that is to the nearest tenth so that you know how to type that in. If you have an older, like the older calculators, remember you need brackets around the fraction. Otherwise, if yours gives you a little box, you can just go 1 over 3. So to 1 decimal place, that is, you should be getting 3.9 meters. Okay, the surface area, I'd like you to type in 60 times 60 to the power of 2/3. Oops, that's a 3. 60 times, no, 6 times 60 to the power of, so if you're putting in an exponent that's a fraction, and you have the other type that shows you the little hat, you need brackets, 2 over 3. So to 1 decimal place, what would that be? 92.0. The 5 rounds the 9 to a 10, right? But we still want that 0. Meters squared. Okay, we're done. The lesson. Couple conclusions. The first conclusion. Square root of x is the same thing as x to the power of what? 1 over 2. The cubic root of x is the same thing as x to the power of 1 over 3. And so therefore, the nth power of x is the same thing as x to the power of 1 over n. Okay, that's one conclusion. The other one, we need to, should have done this on a new page. If you had the square root of x cubed, that's the same thing as x to the power of 3 over 2, power over root. So if we can make the conclusion, if it's m over n, which one's the index? N. And which one's the power? M. And the last one is if we had a negative exponent. The first thing you'd have to do, if you have a negative exponent, flip it, move it to the denominator, and then you can write it as the n. Oh, no. What's the index? Nth root of x to the power. Okay. Those are our conclusions. You have 3 days this weekend, right? So you want to make sure that you get this done, you understand it, you come back with questions. We can go over your questions in class before we start the next lesson. Okay? The assignment is so page 196, numbers 1 to 6 ACE, and then if you have time, 7 and 8, I recommend you try 7 and 8. Okay?